Hello and welcome to Mr. Tompkins EdTech. This video covers pretty much the whole of GCSE Maths in just over 2 hours, covering all the essential topics for both foundation and higher tier students, aiming to get a good pass in their mocks and final exams. So if that sounds like you, then keep watching. You'll find topic lists and timestamps in the video description. As you go through, I highly recommend you use these to make a list of topics that you're not sure about. Afterwards, you can then look those topics up in your revision guides or simply follow the links provided to more focused revision videos on those topics. Higher tier students aiming for grades 7 through 9 will want to watch this next video too, as it contains all those harder topics appearing towards the end of the higher tier paper. If you find it helpful, please do give it a like and subscribe and share the video with your friends. You'll find video walkthroughs of pretty much every exam paper on my YouTube channel, along with revision resources and question compilations on all those key topics you struggle with. As we run up to the exams, I'll be posting important information, predicted questions, and general support and encouragement to help you achieve your target grade this summer. Good luck in your preparations and in your exams. Let's get into it.
Write 120 as a product of its prime factors. Okay, so this is the calculator paper, but if you didn't have a calculator paper or if you don't have a Casio calculator, you're going to have to do this a long way by breaking the number down into factor pairs. All you got to do is think of two numbers that multiply together to give you 120. So I could pick 2 and 60 or 3 and 40, it doesn't really matter. I'm going to go for 3 and 40. Now 3 is prime, so that's a stopping point. 40 isn't, so we can continue to break that number down. So we need to find two numbers that multiply together to give me 40. I could pick 2 and 20 perhaps. So 20 and 2. 2 is prime, so I'm going to stop on that one, but 20 isn't, so I'm going to keep breaking it down. Two numbers that multiply together to give you 20. 10 and 2. So 2 is prime, so I stop on that one. And then finally I've got 10. Factor pairs of 10, 2 and 5. Now both 2 and 5 are prime, so I've kind of come to the end of breaking my number down. So then the product of my prime factors, I can say 120 then is all those endpoints multiplied together. So all of these multiplied together will give me 120. Okay, so what have I got? I've got 1, 2, 3 2s, haven't I? So that's 2 times 2 times 2, and then I've got a 3, and I've got a 5. Okay, now you can rewrite that in index form if you like, just write a bit neater. 2 cubed times 3 times 5. Okay, but as I say, if you've got a Casio calculator, you can just type it into your calculator. If you enter the number 120 and press equals, and then press the fact key, it will do this for you in one step. So yeah, that kind of takes the hard work out of it, and you just need to write the answer down for 3 marks. Amazing. So if you've not got yourself one of these Casio calculators, I highly recommend them. You can find a link to it on my my Amazon shop page. I'll put a link in the video, and you can jump there and order yourself one if you haven't already got one. Right, let's move on. A is a common factor of 72 and 120, and B is a common factor of 6 and 9. Work out the highest possible value of A over B. Okay, so this fraction is going to be its biggest when A is at its maximum value and B is at its minimum value, isn't it? Okay. You'll get a bigger number if you divide a fraction by a smaller denominator. So let's take B to start with then. I think that one's going to be easier. A common multiple of 6 and 9. If we want B to be minimum, we're actually asking for the lowest common multiple of 6 and 9. Okay, so let's think about the multiples of 6 and 9. The multiples of 6 are 6, 12, 18 and so on, and 9 is 9, 18, 27 and so on. So you can see we found our lowest common multiple already. 18 is there, 18 is there. So our LCM then of those two numbers is 18. So that's going to be my value of B. What about A then? We've got A is a common factor of 72 and 120. So let's list out the factors of 72 and 120. I tend to write them down in factor pairs. So 1 goes with 72. 2 goes with, well, half of 72 is 36. I think 3 must go into it then as well. So 3 and 24, is that? 3 and 24. 4 and what? 4 and, that's got to be 18, isn't it? 5, no, 6. Yeah, 6 goes into it. 6 and 12. 7, no, 8, yes. 8 goes with 9. And look, I've met myself coming down the other way, so that's as far as I'm going to get. So quite a lot of factor pairs of 72. What about 120? We're going to have so many. So I've got 1 and 120. 2 and 60. 3 goes with 40. 4, yes, goes with 30. 5 goes with 24. 6 goes with 20. Also got a lot of factors. 7, no. 8, yes. 8 goes with 15. 9, nope. 10, yes. 10 goes with 12. And then I've got 11 in between. That's not going to be a factor. So that's all of them. Gosh, lots of factors for both of those numbers. So we want the HCF then of those two numbers. So we want A to be as big as it can be. So it's going to be the highest common factor of those two. So looking through my list, 72, no, 36 is my next biggest. That isn't on my list. 24, yeah, that's on my list. So look, 24 there, 24 there. So the HCF of these two numbers is 24. Okay, so what's the highest possible value of A over B then? Is going to be, so that was my A value, wasn't it? 24, and B is 18. So my highest value is going to be 24 over 18. Okay. Which I could cancel down, but I'm not sure I need to. So it could simplify to 4/3. Also an acceptable answer. Eve has these coins. So she's got a £2 coin, a £1 coin, 50p, 2 20s, a 5 and a 2 pence. Ola has these coins. She's got a £1, a 50p, a 2p and a 1p. Eve gives 3 of her coins to Ola. Now Ola has the same amount of money as Eve. Which coins does Eve give to Ola? Okay, let's see if we can work this out. Let's work out how much they've got each first off then. So Eve is starting with 2 plus 1, which is 3, plus 50p, plus 20, plus 20, plus 5, plus 2. That adds up to 3, 50, 90, 97. So Ola starts with £3 and 97 pence. Ola has a £1, 50p, a 2p and a 1p. So that is £1 and 53. Okay, so then after Eve gives Ola 3 coins, they should have the same amount. Okay, so how many coins does she give him? Well, if we can work out what the difference is between their two numbers and half it, then we'll know how much Eve gives to Ola. So what is £3.97 subtract £1.53? That is 7 subtract 3 is 4, 9 subtract 5 is 4, and 3 subtract 1 is 2. So the difference between their money is £2.44. So if I half that, £2.44 divided by 2, 2's into £2.44, 2's into 2 go once, 2's into 2 go twice, 2's into 2 go twice, so it's £1.22, isn't it? Okay, so I need to give, well, Eve needs to give Ola £1.22, and that will mean that they have the same amount of money. So if she gives the £1 and the 20p and the 2p, that's £1.22, isn't it? Okay, and then they'll both have the same amount of money. Eve will have £2 left, and the 50 and the 20 and the 5p, making £2.75. And Ola will now have £2 and the 50 and the 20 and the 2 and the 1 pence, which is £2.75 as well. Okay, so how am I going to write that down? Oh, I need to write down in the answer box. So she's given her £1, a 20p and a 2p. So the pound coin, the 20p coin and the 2p coin. Question 19. Cola is sold in packs of 6 and packs of 8. And we can see various prices here. So 1 pack of 6 costs £1.95, or we can buy 2 packs of 6 for £3.50, or we can buy 1 pack of 8 for £2.64 and 2 packs of 8 for £5. What we need to do is work out the cheapest way of buying 48 cans of cola, and you must show your working. Okay, so I think the easiest way to approach this is to work out the unit cost of 1 can from the 4 various deals we've got on offer there, and then work out what the best deal is from that. Now we want to buy 48 cans altogether. 6 is a factor of 48, as is 12, as is 8, and as is 16. They all go into 48, so we can just buy enough packs of the cheapest pack type to get us up to the 48 cans. So just knowing the unit cost of each of the 4 deals should be sufficient for this question. So let's take the 1 pack of 6. So for my 1 pack of 6, so I've got £1.95, which I need to divide by 6. So 1.95 divided by 6 gives me a unit cost of 0.325. So that's the cost of 1 can, isn't it? So then we've got a 2 pack of 6. So that's £3.50. So 2 packs of 6 would be 12 cans. And £3.50 divided by 12 gives me a unit price of 0.292, rounded off to 3 significant figures. Next, let's have a look at the 1 pack of 8. Now that costs £2.64, and I get 8 cans for that, so that gives me a unit cost of 2.64 divided by 8 gives me 0.33 per can. So interestingly, the most expensive. You'd think it'd be the cheaper of the 2, but nope. And then finally, 2 pack of 8 costs £5, and altogether there are 16 cans in 2 packs of 8. So 5 divided by 16 gives me a unit cost of 0.31. Let's round it off to 3 significant, so 3 significant figures as well. 313. So now we've got our 4 different unit costs. Now it's clear now then that this one, 2 pack of 6, is the cheapest unit cost. Okay, so if it's cheapest to buy that per can, then it's going to be the cheapest price altogether. So what is the cheapest way of buying 48 cans? So we need to buy 2 packs of 6. How many times? That's going to be 12 cans, and 12 goes into 48 4 times. So the cheapest way of doing this is going to be to buy 4 lots of 2 times 6 pack. Beth sells hot dogs at a market. Each hot dog is a sausage in a bread roll. Hot dogs £3 each. The table shows her costs. Fees paid to the market £240. Bread rolls 42p per pack of 6. Sausages £2.50 per jar of 10. Other costs £57. Now it says that Beth sells the hot dogs for £3 each, and she sells 300 hot dogs, and we need to work out her total profit. Okay, well, our total profit is going to be total income minus total expenditure. So your money coming in less your money coming out. So we need to work out those two amounts, don't we? So let's work out income first. How much money she's got coming in. So we know how much money she's coming in from this part down here, don't we? Okay, so that's where we get our income from. Beth sells hot dogs for £3 each, and she sells 300 hot dogs. So that's quite simple. So income is going to be her £3 per hot dog times her 300 hot dogs. 3 times 300 is £900. So that was nice and easy. What about expenditure? So that was money coming in. What about money going out? Expenditure. So what has she got? So her total expenditure then is going to be the £240 from the fee paid to the market. She's got 42p per pack of 6 bread rolls. So how many bread rolls is she going to need then? If she's made 300 hot dogs and bread rolls are in packs of 6, then what's 300 divided by 6? 6 is into 300 go 50 times, so she's going to need 50 packs of those bread rolls. So that's going to be 50 times 0.42. Okay. Sausages, £2.50 per jar of 10. So 300 divided by 10 means I need 30 jars of sausages. So I need 30 jars at £2.50 each. And I've got 57 other costs. Okay, so then in total then, my total expenditure is going to be 240 plus 50 lots of 42 pence. So 50 times 0.42, that comes out to be £21. I've got 30 lots of £2.50. 30 times £2.50, that comes out to be £75. So my total expenditure is going to be those 4 amounts added up then, isn't it? So expenditure then is going to be 240 plus the 21 plus the 75 plus the 56. 24, 240, 21, 75, sorry, 57. £57 in other expenditure, which comes to 240 plus 21 plus 75 plus 57. That means her total expenditure is £393. Okay, so what's her profit then? So profit is going to be income less expenditure, which is going to be her £900 that she made less the £393 that she spent. That comes out to be £507. So she's made a good profit on those hot dogs. £507. Between January 2015 and January 2016, the price of diesel increased from £1.12 per litre to £1.19 per litre. Calculate the percentage increase in price. Okay, now I tend to use this triangle when I do percentage questions. FOM, stick your thumb on it. F stands for final, original, and multiplier. Okay, and it's arranged like this into a triangle, FOM. Okay, so what does the F stand for? F stands for final, so it's the last price. It's going to be that one there, £1.19. It increases from £1.12 to £1.19. So £1.19 is the end price, or the final price. O stands for the original. Okay, so what was it to start with? It was £1.12 per litre, wasn't it? So that's our original price. That's going to be £1.12. And then multiplier, well, that's what we're trying to find, isn't it? Okay, so then what we do is we take our little FOM triangle, we cover up the one we want to find. I want to find the multiplier. And that tells me what to do with the other two. So multiplier That's going to be the final price divided by the original price. Okay, so then subbing in the values I've got here. Final is £1.19. Original is £1.12. Okay, so then I just need to tap that into the calculator then. £1.19 divided by £1.12. That comes out to be 17/16 or 1.0625. 1.0625. Okay, now that's a decimal. To convert it into a percentage, you need to times by 100 or shift the decimal point 2 places along, so that's 106.25%. Now remember, we want to work out what the percentage increase is. Okay, so when you're doing percentage increases, you always start with 100%. So if I started with 100% and then now I've got 106.25%, that is an increase then of 6.25%. Okay, Tom invests £2,000 at 5% per year simple interest. How much interest has been paid after 6 years? Okay, now note this is simple interest, not compound interest. We are not putting the interest into the account and then in the second year calculating the interest on the original amount plus the previous interest. It's just going to be the same amount each time. So if 100% of something is £2,000, then what's that? 10% would be 200. 5% is going to be 100. Okay, so that's what 5% interest would be. Now we're going to apply that 5% interest 6 times over because we've got 6 years to do it. So our amount, how much interest has been paid after 6 years, is just going to be 6 lots of £100, isn't it? Which is £600. Part B says Tom receives a 20% wage increase. His new weekly wage is £360. Calculate his weekly wage before the increase. Okay. So with percentage questions, I often do these triangles, FOM, just to keep track of what I have to multiply or divide by what. So F stands for final, O stands for original, M stands for multiplier. You can apply it to all sorts of percentage questions. So then we just need to go through and work out which is which. So he receives a 20% wage increase. His new weekly wage is 360. And we want to work out his weekly wage before. Okay, so final is what it was at the end, so that's going to be his new weekly wage, isn't it? So that's going to be 360. The original, well, that's what we're trying to find, his weekly wage before the increase, and then the multiplier is going to be the 20% increase, isn't it? But remember, we start with 100%, so if we increase it by 20%, we're now at 120%, which is a multiplier is 1.2. Okay, so now we cover up the thing we want to find. So I want to find the original, and then that tells me what to do with the other two. So using my little triangle, original equals final over multiplier. In other words, it is 360 divided by 1.2. Okay. Okay, to make things a little bit easier for ourselves, I'm just going to multiply top and bottom by 10. So that's 3,600 divided by 12. Because it's a non-calculator paper, isn't it? I haven't got a calculator to tap it in. So 12's into 3,600. Well, 12's into 36 go 3 times, and then I've got 2 extra zeros, so it's going to be 300, isn't it? £300. Here are the interest rates for 2 bank accounts. We've got Northern Saving Bank, which is 2.5% per year compound interest, and Central Alliance Bank, which is 2.7% per year simple interest. Mia puts £6,400 in each account. Calculate the difference in value between the two accounts after 8 years. Give your answer correct to the nearest penny. Okay, so I'm going to work them out separately and then I'm going to compare them then. So let's start off with the Northern Saving Bank, NSB. So working out compound interests, the final amount is going to be the original amount times the multiplier raised to the power of the number of years. That's the formula for compound interest. So what is the final is what we want to find, isn't it? Original, what's the original? It is what she put in the bank account, which is 6,400. And the multiplier is going to be 100% plus 2.5%, which comes to 102.5%, which as a multiplier is going to be 1.025, then, isn't it? So that's the multiplier we're going to use here. So my final amount is going to be my original amount, which is 6,400 times by 1.025 raised to the power of 8. Now, tapping that into my calculator, because I can't do that sort of maths in my head. 6400 times 1.025 to the power of 8. That comes out to be £7,797.78. So I'm just going to write that down to the nearest penny. 7797.78. 7797.78. Okay. Now for the other bank account, that was CAB. Can just scroll up a bit, give myself a bit more space. So let's work out the second base now, CAB. CAB Bank. Again, the final is going to be original times multiply, but I need to find them a slightly different way here. Well, the multiplier part anyway. Final is just the same. The original is just the same. Still 6,400. Multiplier. Now I'm starting with 100%, and I'm going to be adding on 2.7% 8 times. So I'm just going to multiply that by 8 and work out one multiplier. So 2.7 in my calculator times 8, that comes out to be 21.6%. So add that to 100% is 121.6%, which as a multiplier is going to be 1.216. Okay, and then final amount, it's just going to be my original amount times my multiplier. Don't have to compound it this time, so I'm not raising it to a power, and I've already applied it 8 times. So it's just going to be a straightforward multiplication. So my 6,400 times 1.216, that comes out to be 6,400 times 1.216. I make that £7,782.40. £7,782.40. Okay, which you'll notice is slightly lower than the compound interest amount, which is, I suppose, the point of what we're looking at here, isn't it? So what is the difference between the two? Work out the difference between the two. So subtracting one from the other. So then the difference is going to be 7797.78 subtract 7782.40. What's that then? 7797.78 subtract answer. That comes out to be a difference of £15.38. 15.38. Okay, that's my final answer then. That's my difference to the nearest penny. The height of Zach is 1.86 meters. He's a big boy. And height of Fred is 1.6 meters. Write the height of Zach as a fraction of the height of Fred. Give your answer in its simplest form. Write the height of Zach as a fraction of the height of Fred. That means Zach's height goes on the top and Fred's height goes on the bottom. So it's going to be 1.86 divided by 1.6. Now again, we've got decimals here, which we can easily get rid of by multiplying top and bottom by, well, let's do it by 100. So what's that? What will that give me? That will give me 186 over 160, won't it? So it's a top-heavy fraction. Right, so we're looking for common divisors now. 160 and 186. Well, struggling to find a common divisor. Bigger than 2. Let's just halve it and see. Have another look. So that would be 93 over 80. Okay, any common factors there again? 3, nope. 7, nope. No, I can't think of any more. No, I think that's about as far as I'm going to get with cancelling down. Now it's asking for the simplest form here, so we cancel down as far as we can. Now we could write it as a mixed number. We could write it as 1 and 13 over 80. But I don't actually think that is any more simple than this. I prefer to leave my answers as top-heavy fractions. I think they're more useful, so I'm going to leave it like that. Calculate 3/5 plus 5/8. Okay, so we're adding fractions together here, but you'll notice that we've got different denominators. We've got a 5 here and an 8 here. So to add them together, we need to find a common denominator. So what's a common multiple of 5 and 8 then? The smallest one I can think of is, well, it's just 5 times 8 is 40, isn't it? So let's times the first fraction top and bottom by 8 and the second fraction top and bottom by 5. What's that going to give me? So that's going to give me 3 times 8 is 8, 16, 24 40ths plus 5 times 5 is 25, 25 40ths. So now I've got two numbers with the same denominator. I can simply add the numerators together then. So the 24 plus the 25. That gives me 49 over 40. Okay, so that's an improper fraction, and in a lot of cases that would be perfectly acceptable. It's just that in this particular case it's asking me to express it as a mixed number, not as an improper fraction. So we're going to convert this into a mixed number by saying how many times does 40 go into 49? It goes in once, and the remainder is 9, so it's 1 and 9 40ths. Just double check, have we got any common divisors of 9 and 40? Nope, don't think so. So I think we're done. So it's 1 and 9 40ths. Write the ratio 6 millimeters to 180 centimeters in the form 1 to n. Okay. Now, when you're comparing things in a ratio, you should really have the same units, and these are not the same, are they? I've got millimeters and centimeters. So I'm going to have to convert them all into the same unit. It's going to be easier to go from centimeters to millimeters, I think. You should know that 1 centimeter is the same thing as 10 millimeters. So if I take the centimeter one and I multiply it by 10, I'm going to get millimeters then, aren't I? So the ratio is going to be 6 to 180 times 10. So that's 1,800. Okay. Now I want to have 1 here, which means I need to divide through by 6. So doing the same thing this side. Dividing through by 6. 1800 divided by 6. I can just do that in my head. That's 300. Okay. So write the ratio in the form 1 to n. It's 1 to 300. Adil, Kate and Rebecca share £160 in the ratio of 2 to 5 to 3. How much does Rebecca receive? Okay. So within these questions then we need to work out how many shares there are altogether. And we can do that by just adding the ratio bits together. So 2 plus 5 plus 3. That tells me that there are 10 shares altogether. Okay, now if there are 10 shares and we're sharing £160, then each share is going to be 160 divided by the number of shares, 10. So that's going to give me £16 per share. Okay, and then we've got in the ratio of 2 to 5 to 3 to start with. So scaling that up then by a factor of 16. That means that Adil is going to get £32. Katie, is going to get £80. and Rebecca is going to get 3 lots of 16, which is 48. Now I've done a bit more work than I need to do here, but it's good practice just to double check your 3 amounts actually add up to what you started with, and 32 and 18 and 48 does add up to 160. So I'm feeling pretty confident that I've got my answer right. So £48 for Rebecca. A box contains only red, blue and green pens. The ratio of red pens to blue pens is 5:9, and the ratio of blue pens to green pens is 1:4. Calculate the percentage of pens that are blue. Okay, so I've been given 2 ratios here, and they're kind of separate from each other, aren't they? So what I'm going to do first is I'm going to try and combine them into one ratio that has all 3 elements in it. So I've got red, and I've got blue, and I've got green, haven't I? And I know from the first statement that the ratio of red to blue is 5:9. So I can put a 5 in there and a 9 in there. And then from the second statement, I know that blue pens to green pens is 1:4. So I can put a 1 in there and a 4 in there. Okay, so notice I've got 2 blue numbers, I've got a 9 and a 1. Now if I can take this second ratio, 1:4, and scale it up so that 1 becomes a 9, then I can kind of combine the 2 together. So that's what I'm going to do. I'm going to take this second ratio here, and I'm going to multiply it up by a factor of 9. And that's going to give me a ratio of blue to green of 9 to 36. Okay, and you'll see now that that 9 there matches with that 9 there. So that means I can bring down this 5 and write it in here. So I've got a kind of a super ratio now that's got all 3 bits included. So the ratio of red to blue to green is 5:9 to 36. Okay, now we know that, we can work out the percentage of pens that are blue, because we know that there are 9 blue pens for every 5 plus 9 plus 36 pens there are. So it will be percentage blue, it's going to be that 9 divided by 5 plus 9 plus 36 made into a percentage. Okay, so what's 5 plus 9 plus 36? That is 50, isn't it? So it's 9/50ths. Well, I might just make that into 1800ths and say that's 18%. Advertisement break. Looking for a maths tutor to help you through your GCSE, A-level or IB exams? Then why not check out Mr. Tompkins Tutors at mr.tompkins.online/tutors. Mr. Tompkins Tutors offers personalised one-to-one quality tuition online via Teams direct to your home. Tuition is delivered by myself and a team of first-rate teachers who I've personally known and worked with for years. All have qualified teacher status in the UK and a recent full DBS disclosure, so you can be confident that you're in good hands. To find out more and request a trial lesson, simply visit the website linked below and complete the online form, and we'll be in touch with you soon. Until then, by writing each number correct to one significant figure, find an estimate for this calculation. Now it's really important that you read these sentences above the calculation. Some people just see this and they'll start focusing on that straight away, and they won't read the sentence that goes above it. You really need to make sure that you do. This one is giving you some very clear instructions. They're asking you to estimate. I've actually given you more information than they need. They don't normally tell you this bit. So we're going to write each number correct to one significant figure. Even if they told me to estimate it, that's what I would have done anyway. So a bit weird that they should tell you. But anyway, 606.3. What's that number correct to one significant figure? Well, the first significant figure is the first non-zero digit, which is that 6 there, isn't it? Which is in the hundreds column. So rounding 606.3 to the nearest 100 is going to be 600. Okay. And the second number, the first significant figure is the first non-zero digit. It's that one there. It's the 3. That's in the tenths column. So if I round off to one significant figure, I'm going to round off that number to the nearest tenth. So am I going to round up or down? Just look at the number next to it and to decide whether or not it is 5 or more or 4 or less. In this case, it's 4 or less. So I'm just going to round down to 0.3. Finally, 19.93. The first significant figure is that 1, which is in the tens column. So rounding 19.93 off to the nearest 10, that's going to be 20 then, isn't it? So my calculation becomes 600 times 0.3 divided by 20. Okay, so let's do the maths then. What's 600 times 0.3? That's the same thing as 60 times 3, isn't it? So that is 60, 120, 180. 180 over 20. Just cancelling those zeros out. 18 divided by 2. That's going to give me an answer of 9. Okay, so that's my estimate. The length of a table is 110 centimeters to the nearest centimeter. Complete the error interval. Okay, so I tend to draw a line when I do these, and I mark the number I've been given. Now this is to the nearest centimeter. So on my scale, I'm going to go up 1 centimeter, so that would be 111, and down 1 centimeter, that would be 109. Now the numbers that round to 110 are the numbers that are going to be halfway or closer to 110. So it's all these numbers in here. These are the ones that round to 110, aren't they? And halfway between 109 and 110 is 109.5, and halfway between 110 and 111 is 110.5. So they're going to be my boundaries. Now notice really 110.5 would round up, which is why you've got this strictly less than sign in here. Work out cube root of 4096. Now this is a job for the calculator. Now your calculator, if you've got a scientific calculator, should have a cube root button of some sort. Sometimes it is written like this if you've got a cube root button. Some calculators don't have a cube root, but they have an X root button that you can use, or might have a little square like this. So one of those symbols there. Now luckily my calculator does have a cube root button, so I can just press shift and then that cube root button and then type in 4096 and then press equals, and it gives me the answer of 16. Now clearly you need to know how your calculator functions to find cube roots. Similarly, my next question is work out 3 to the power of 7. Now again, different calculators have a power key that's written slightly differently. Some of them are written like x to the n. Some of them have a little x and a little square where the power should be. Some of them just have like a little up arrow like that. Again, you need to work out which is your power button. Mine looks like this. I'm going to press 3 to the power of 7 equals, and my calculator gives the answer as 2187. 2187. Work out 512 divided by 5 to the power of 3 times 5 squared as a power of 5. Okay, I'm just going to use the fact that when I multiply two numbers with the same base, I subtract. When I multiply them, I add the indices, and when I divide them, I subtract the indices. So this is going to be the same as 5 to the power of 12 subtract 3 plus 2. So 12 subtract 3 is 9 plus 2 is 11. So that's equal to 5 to the power of 11. It's that one there. Write the number 6,005,200 in standard form. Okay, let's try and write it out as a number first off. So 6 million is 6 followed by 6 zeros. Well, 6,005,000, so that's going to be 005,200, like that. 6,005,200. Okay, now we've got it written as a number. Now we can try and write it in standard form. So we're just going to write all the digits. 6.0052. I can forget about the last two, so I'm not going to change it either way. So times what? 10 to the power of, well, if the decimal point starts here and we're going to end up 1, 2, 3, 4, 5, 6, we're going to move it 6 jumps to get it to there, aren't we? So that's times 10 to the power of 6. So my answer is 6.0052 times 10 to the 6. Match each sequence to its description. One has been done for you. You can see here we've got 1, 2, 3, 4, 5, 6 different sequences, and the first one is mapped as a Fibonacci sequence. It is, look, so 1 plus 1 is 2, 1 plus 2 is 3, and with a Fibonacci sequence you get the next number in the sequence by adding together the last two. You can see that's the case all the way through there. What about the next sequence? I've got 1, 2, 4, 8, 16, 32. Now, from one term to the next, you can probably see that I'm multiplying through by 2. It's doubling each time, isn't it? It's times 2. So times 2 times 2 times 2. So anything that has a common ratio like that, multiplied through by the same number, that is a geometric progression. Next one, 1, 2, 3, 4, 5, 6. That one is going up in even jumps. It's plus 1 each time, plus 1, plus 1, plus 1. So any sequence that's going up in a fixed number each time, that's an arithmetic progression. Okay, what have we got now? 1, 3, 6, 10, 15, and 21. Now, if you drew those as a sequence of dots, I think you can probably see that this is the triangle numbers. It's that one there. 1, 4, 9, 16, 25, 36. I hope you can recognize is the square numbers, and that leaves me with the cube numbers 1, 8, 27, 64, 125, 216. Yep, that all looks good. Okay, all done. A linear sequence starts 11, 21, 31, 41, and so on. Okay, now if it's a linear sequence, it's going to have gaps in between that are equal, aren't they? So this is a plus 10 sequence. Can you see it's 10 between each numbers? And that means the nth term is going to be something like 10 lots of n. So where n is 1, 2, 3, 4, then 10n is 10, 20, 30, 40, and so on. But we've not got 10, 20, 30, 40. We've got 11, 21, 31, and 41. Now each of our numbers is one more than 10n. So we must have 10n plus 1. And that is my nth term, 10n plus 1. The nth term of a sequence is 5n subtract 2. Work out the third term. Well, if it's a third term, then that means that n must be 3. As n stands for whichever term is in the, whichever position is in the sequence. So if n is 3, then 5n subtract 2 is going to be 5 lots of 3 subtract 2. 5 3s are 15, and 15 subtract 2, that is equal to 13, so it's that one. Simplify 3a plus 7b minus a plus 4b. Okay, so we need to collect like terms. So we've got terms in a, 3a minus a, and we've got terms in b, plus 7b and plus 4b. Now notice when I highlight those I highlight the sign that goes in front of them, because that is part of what we're doing, isn't it? So 3a subtract a is 2a, and 7b plus 4b is 11b. So we get 2a plus 11b. Expand 4 lots of 2d plus 5. So single brackets, a number on the outside, that gets multiplied by everything inside the bracket. So 4 times 2d is 8d, and 4 times 5 is 20. There's a plus sign in the middle, so it must be plus 8d plus 20. I've got a pair of brackets to remove. So I don't know how you remember this. It might be first, outside, inside, last. Might be something like that, or you might have a smiley face. Whatever way, you can work out that you have to multiply everything in the first bracket with everything in the second bracket. Y times y is y squared. Y times negative 4 is minus 4y. 5 times y is plus 5y. And 5 times minus 4 is minus 20. At this stage here, just look in the middle for your two like terms and add them up. So I've got y squared minus 4 and plus 5 make y. So my final answer is y squared plus y minus 20. We're asked to factorise 15x plus 18y. Now that's pretty much the opposite of what we were just doing. Expanding removes brackets and factorising puts them back in. The thing that goes on the outside of the bracket is the thing that's common to both terms. So we've got an x in one and a y in the other, so they're not common, but we've got a 15 and an 18. 15 and 18 are both in the 3 times table, so I can put a 3 on the outside. Now to work out what goes on the inside of the bracket, we just need to think about, well, what 3 times what is going to give me 15x? Well, 3 times 5x gives me 15x. I'm going to have a plus in between. And 3 times what gives me 18y? Well, 3 times 6y must give me 18y. So I get 3 lots of 5x plus 6y. Factorise x squared minus 9x plus 20. So we've got a quadratic expression and we want to factorise it. If it factorises, it will go into a double bracket like this, won't it? It starts with x squared, so I'm going to have an x and an x. Now I'm looking for a pair of numbers that multiply together to give me plus 20 and add up to negative 9. Okay, so thinking about the factor pairs of 20 first off. 20 you can get by multiplying 1 and 20 together, or 2 and 10, or 4 and 5. They're the factor pairs of 20. So we want one that adds up to negative 9. Okay, well, because I've got a positive number at the end and a negative number in the middle, I must have minus and minus, so these must all be negative values. Negative, 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 negative. And which pair adds up to negative 9? It's this one here. So it's going to be minus 4, minus 5. X minus 4, x minus 5. Solve x squared minus 9x plus 20 is equal to 0. Now that's the same expression as we've got above. So I can just factorise it the same way. X minus 4, x minus 5 is equal to 0. Now when you have two things that multiply together and give you 0, it means one of them must have been 0 to start with. So either x minus 4 is 0, in which case x is 4, or x minus 5 is 0, in which case x is 5. So my answer is x equals 4, x equals 5. Two solutions. Solve the equation 3x plus 14 is equal to 2. Right, so subtract 14 from both sides, or change sides, change signs to move the 14 to the other side. I'm going to get 3x. Those two things are going to cancel each other out. And I'm going to get 3x is equal to 2. Subtract 14, which is minus 12. Then dividing both sides by 3. I'm going to get x is equal to minus 4. X is minus 4. Solve the equation 5x plus 1 is equal to 2 lots of x plus 4. So we want to get all the x's on one side and the numbers on the other. But let's try multiplying out this bracket first. Don't always have to multiply it. Sometimes you can divide by the number on the outside, but here we've got x's on both sides. So I think it's going to help to multiply it out first. So 5x plus 1 is equal to 2 lots of x, which is 2x, plus 2 lots of 4, which is 8. Okay, so you can see that we've got unknowns on both sides here. So let's subtract 2x from both sides. So that will leave me with 3x plus 1 is equal to 8. And we've also got numbers on both sides. So let's subtract 1 from this side and also 1 from here. That's going to give me 3x is equal to 7. And then dividing both sides by 3, I'm going to get x equals 7 over 3. Now 7/3, a top-heavy fraction or improper fraction like that, is a perfectly acceptable answer. So you can just leave it in that form there. It's probably the easiest way of doing it. So just leave it like that. Rearrange x equals 2y minus 6 to make y the subject. Okay, so I've given this. You can do this pretty similar to how you would solve an equation, just trying to get y by itself basically. So we can start by adding 6 to both sides. That bit will cancel with that, leaving you with 2y on the right. and then x plus 6 on the left, and then we're going to divide both sides by 2. Okay, so then that cancels with that, leaving me with just y. Y is equal to x plus 6. I'm just going to leave it like that, x plus 6 all over 2. Okay, that's my answer. Y equals x plus 6 over 2. The rectangle has length 2x plus 5 centimeters and width x minus 2 centimeters. The rectangle has an area of 35 centimeters squared. Use algebra to find the value of x. Okay, so area of a rectangle is just length times width, isn't it? Okay, now we know the area. We're told it's 35. We know the length. It's 2x plus 5. We know the width. It's x minus 2. Okay, so solve for x. Okay, so we've got a quadratic coming on, haven't we? So we've got a pair of double brackets that we're going to need to multiply out. So that times that, that times that, that times that, that times that. So I'm going to get 35 is equal to 2x squared plus 5x minus 4x minus 10. Okay. Then what I'm going to do is going to collect everything on one side. So that 35 sitting there, I'm going to move over to the other side. So collecting like terms, 2x squared, 5x take away 4x is x, minus 10 with my other 35 coming over is going to be minus 10 minus 35, which is minus 45. And that's going to be equal to 0 because there's nothing left on the left. Okay, so I've got 2x squared plus x minus 45. Can I factorize that? I hope so. Okay, so common factor, well, common factor pairs of 45. Got 1 and 45, 2, no, 3, no, yeah, 3 and 15. 5's got to be in there, isn't it? 4, no, 5 and 9. 6, no, 7, nope. 8, nope. So, which one of those pairs is going to work? Now remember, I'm going to have 2x and x in here, so the order I put them in is going to affect the middle one as well, isn't it? I'm thinking it's going to be this pair here. Okay, because if I put the 5 at the end here, plus 5, it's going to be multiplied by the 2x, give me 10, and then the 9 here, which is negative, 10 subtract 9 is going to give me the 1 in the middle. So it's 2x minus 9x plus 5. Okay, that's equal to 0. So that's going to give me solutions of x equals 9 halves, 9 over 2 here, which is 4.5, or x equals minus 5. Okay, now does that make sense in this question? Because if x was minus 5, then up here, look, I would get 2 lots of minus 5, minus 10 plus 5, which is a negative number, and I can't have a rectangle with a negative value in reality, so that one is not a solution. Okay, it's a solution to my quadratic, but it's not a solution to this problem. Okay, so I'm just going to ignore that one. I'm instead going to use the x equals 9 over 2 or 4.5. Okay, so x is 4.5. Solve the simultaneous equations. 3x plus 2y is equal to 10 and 3x minus y is equal to 13. Now you notice that these two values of x, the coefficients, are the same. So this question lends itself very well to solving by elimination. So let's call this one equation 1 and this one equation 2. Then equation 1 subtract 2. So taking the second equation away from the first, so 3x take away 3x, they're going to cancel each other out, aren't they? Just take care when you're subtracting negative signs here. So 2y take away negative y is 3y, and 10 take away 13 is minus 3. So that's going to give me y is equal to minus 1. Okay, so now substituting back into one of our equations, substitute y equals -1 back into, should we pick equation 1? So then I've got 3x plus 2 lots of -1 is equal to 10. 2 minus 1 is -2. Taking that to the other side. So taking that over there, I'm going to get 3x equals 12, give me x is equal to 4. So that would tell me that x is 4, y is -1. Always a good idea to check these just by subbing both values into the second equation, the other equation we didn't use. So 3x minus y equals 13. So 3 lots of 4 minus -1. Is that equal to 13? 12 subtract -1, 12 plus 1 is 13. So yes, it does work. Always a good idea to do checks in the exam. You'd better to find out in the test that you're wrong rather than when your results come back. Solve the inequality 3x divided by 2 is less than or equal to 9. Now, as long as we don't divide through by a negative number, we can treat these pretty much the same way as we solve any linear equation. So the first step I'm going to do is to take that 2 and cross multiply it. So move it across the equal sign, or not the equal sign, the less than or equal to sign. So that's going to give me 3x is less than or equal to 9 times 2, which is 18. 3x is less than or equal to 18, and then dividing both sides by 3 is going to give me x is less than or equal to 6. Okay, in the second part, solve the inequality 4 lots of x plus 2 is greater than 12. Okay, the first thing I'm going to do is divide both sides by 4 to get rid of that 4 on the outside of the bracket. So that's going to give me x plus 2 is greater than 3. And then moving this plus 2 to the other side, I'm going to get x is greater than 3 subtract 2. X is greater than 1. Finally, represent the solution set that satisfies both answers to part A and B on the number line. Okay, so from the first part we had x is less than or equal to 6. So x must be less than or equal to 6. And in the second part we had x is greater than 1. So x got to be between 1 and 6. It can include 6, but it cannot include 1. Okay, I'm going to show the range by drawing a line from 1 up to 6. So I'm going to draw a line from 1 to 6. Now the ends of the line depend on the sign. So if it's strictly greater than or strictly less than, we do an open circle. So at 1 I'm going to have an open circle. And if it includes the endpoint, like at the 6th end, we're going to do a filled circle. Okay, so because this sign is strictly greater than, we've got an open circle. And because this one is a less than or equal to sign, we've got a filled circle. On the grid below, draw the graph of x plus y equals 2 for the values of x from -3 to 3. Okay, so we need to work out our coordinates so we can plot this graph. Okay, now the easiest way to do that is to create a table of values. So pulling up a ruler, let's make a little table for our x values and our y values. Okay, so we know that this range goes from -3 to 3. Now you need a minimum of 3 points, but there's no harm in doing it a few more. So -3, -2, -1, 0, 1, 2, 3. Massively overkill. Probably only need 3 or 4. But anyway, it's not a very difficult question. So x plus y equals 2. That means y is going to be 2 subtract the value of x, rearranging that for y. So we can find the y value by taking the x value away from 2. So if x is 3, then y is going to be 2 minus 3. 2 minus 3 is -1. If x is 2, then y is 2 minus 2 is 0. If x is 2, then y is 2 subtract 1, which is 1. If x is 0, then y is 2 subtract 0, which is 2. If x is minus 1, then y is 2 subtract negative 1. 2 subtract negative 1 is the same as 2 plus 1, which is 3. I think you can see the pattern going on here. It's going to be 4 and 5, isn't it? Okay, so I've got minus 3, 5 to plot. Minus 3, 5. Minus 2, 4. Minus 1, 3. 0 goes with 2. 1 goes with 1. 2 goes with 0. And 3 goes with minus 1. And notice they're all in a nice straight line. It was a linear function, so you'd expect it to be in a straight line. If it wasn't a straight line, you should be asking yourself some questions. Okay, so now they are all in a nice straight line. Let's pull up a ruler and let's join them up. Now your line should stretch the full width of your graph. Shouldn't start and stop with the first point. The graph does continue in either directions, so your graph should show that. Okay, so there's my line. Complete the table of values for y equals x squared minus x minus 2. So they've given you some of the values and they want you to find some more. Now it's usually a good idea to start with a positive end because that's a little bit easier to work out. And you might want to just double check your understanding by picking firstly a pair of values that you do know both of, just to make sure you understand what it is you're meant to be doing. So if I did input 3 into this function, I would get 3 squared minus 3 minus 2. 3 squared is 9, take away 2 is 6, take away 2 is 4. Yeah, so that's right. Okay, so that is what I'm going to be doing for each of these questions. So then if I put 2 squared in and I take away 2 and then another 2, 2 squared is 4, take away 2 is 0. Then I've got minus 2, minus 2. Can you see it's repeating itself? So that's probably the point where it turns around and starts going up. So I'm already thinking this is 0 and 4 here, but I'm just going to double check. So put minus 1 in, minus 1 squared minus negative 1 minus 2. Negative 1 squared is positive 1. Take away negative 1 is positive 1. So that's 1 plus 1. Take away 2 is 0. So yeah, that is 0. And then for minus 2, minus 2 squared minus negative 2 minus 2. Negative 2 squared is positive 4. Minus negative 2 is plus 2. So that gives me 6. Take away 2 is 4. Okay, so it is what I thought it was going to be. Right, so draw the graph of y equals x squared minus x minus 2 for the values of x from minus 2 to 3. So basically we just need to plot those points on. Minus 2, 4. Minus 2, 4 is up here. What's next? Minus 1, 0. Minus 1, 0. 0 minus 2. 0 minus 2. 1 minus 2. 2, 0. And 3, 4. Okay. Now this was a quadratic equation, so we were expecting a parabola, and that is what we've got. So I'm feeling pretty confident here that we've got it right. The last part is to draw a continuous curve passing through each of your points. You don't have to be Leonardo da Vinci, but try and get it to be as smooth as possible. What you don't want to be doing is put in like 2 marks on your paper. That will get marked down. Okay, and make sure you're using a reasonably sharp pencil. And make sure you go through each of the points. I'm a bit off on that one actually. It's good to go through the center of each one. Okay, 6C says write down the x coordinate of the turning point of the graph. Now my turning point is this point here, isn't it? That's where the graph stops going down and starts going up again. Now we only want the x coordinate, so just reading up to the line, I can see that that's going to be at a half. So the x coordinate is a half. Interestingly, they don't want the y coordinate here. Okay. A straight line has gradient 4 and passes through the point 5, 23. Work out the equation of the line. Give your answer in the form y equals mx plus c. Okay, So we know that the equation of this line is of the form y equals mx plus c, and we're told here that the gradient is equal to 4, and that means m equals 4. So I know the equation already is of the form y is equal to 4x plus c then. So all I really need to do is find c. Now the second bit of the information tells me that my line passes through the point 523, so I can use that information. Passes through 523, so that's the x coordinate there, isn't it? And that's the y coordinate. So if we sub those into the equation, they should work because it's a point on the line, and then the only thing that I don't know there is going to be c then. So subbing those in, so 23 is equal to 4 lots of 5 plus c. What's that? Let's just multiply out those brackets. 4 times 5 is 20, isn't it? So I've got 23 is equal to 20 plus c. Let's just subtract 20 from both sides. It's going to leave me with c equals 3. So now I know all the pieces. I've got m, I've got c. I can write down the equation. It is y is equal to 4x plus 3. We're told that y is directly proportional to x, and we've been asked to complete the table. Now, if y is proportional directly to x, then y is going to be equal to k lots of x, where k is some constant that we can find. Now we've got a pair of values that go together here. When x is 7, y is 63, so let's sub those in. So when x is 7, y is 63, so 63 is equal to k lots of 7. So that makes k equal to 63 divided by 7, which is 9. So our full equation is y equals 9x. So now very simple to fill out the rest of the table. If x is 0, then 9x is 0. If x is minus 8, then 9 lots of minus 8 is minus 72. All done. Y is inversely proportional to x. Complete the table. Okay, so y is inversely proportional to x. That means y is inversely proportional, little fishy, over 1 over x. Okay, so that's what that is saying mathematically. Now we can replace the little fishy symbol with equals k. So I'm going to rewrite that. So y equals k over x, where k is a constant that we can then find. Okay, now you can find the constant k if you've got two values, well, your value of x and your value of y that go together. Now we've got one of those in the table. If you look at this table, I've got two numbers here that go together. When x is 6, y is equal to 4. So subbing x equals 6, y is equal to 4 into my partial equation, y equals k over x, I should be able to find out what k is. So that becomes 4 equals k over 6, replacing y for 4 and x for 6. Okay, then just taking that 6 there, cross multiplying up there, or multiplying both sides by 6 if you'd rather, I'm going to get k is equal to 24, aren't I? Okay, so my complete equation then is going to be y equals k, which we've now found to be 24, over x. Okay, so now this is my complete equation, which I can then go and find my other values. So if x equals 12, then y is 24 over x. Y is 24 over 12. 24 divided by 12 is 2. So when x is 12, y is 2. And what about the other way around? So if y is 8, what is x? Okay, so if 8 is equal to 24 over x, just cross multiplying these two, just switching them around, I'm going to get x equals 24 over 8. 24 divided by 8 is 3. So x is 3 when y is 8. Once you've done a few of these proportional questions, they get very, very formulaic. they always start off by giving you the rule that links y and x. You can then form your partial equation, which involves the constant k, and then you'll have a pair of values that you can sub in to find what k is to complete the equation, and then you can go on and use your complete equation to find other values. They're always the same, very, very formulaic questions, and after you've done a few, you should be good on them. An athlete runs 240 meters in 45 seconds. Work out her average speed in kilometers per hour. Okay, well, I've got another triangle, handy triangle for distance, speed, time. This time I've got D on the top. These are alphabetical, D, S, T, distance, speed, time. And again, I'm going to do it pretty much the same way as I did the percentage problem. Going to look at what I've got, what I haven't got, and then use the other two to work out the missing one. So an athlete runs 240 meters, so that's going to be my distance then, isn't it? 240 meters. So that's 240 m. Speed, well, that is what I want to find. And then time, 45 seconds. So that is 45 seconds. Okay, so then my speed, covering up the thing I want to find speed. That tells me what I have to do with the other two. So average speed equals distance divided by time. Now if I just go ahead and sub those numbers in, I'm going to sub in meters and seconds into this calculation, and it's going to give me an average speed in meters per second. But this particular calculation, we're being asked to put it into kilometers per hour. Okay, so before I sub these numbers in, I'm going to convert them into the right unit. So 240 meters, what's that then in kilometers? That's going to be, well, there are 1,000 meters in a kilometer. So I need to divide 240 by 1,000 then, don't I? That's going to give me 0.24. It's 0.24 kilometers. And then time, 45 seconds. What is that in hours? Well, it's going to be, there is a, 60 seconds in a minute and 60 minutes in an hour. So if I want to convert seconds into hour, I need to divide by 60 seconds and I need to divide by another 60 seconds. So what's that equal to? 45 divided by 60 divided by 60, 1/80th, which is 0.0125. Okay, so then subbing that in, distance is 0.24, time is 0.0125, so then 0.24 divided by 0.0125, that comes out to be 19.2. 19.2 kilometers per hour. Okay, so 19.2. An alloy is made from 28 centimeters cubed of copper and 41 centimeters cubed of gold. So those two amounts, they're actually volumes, aren't they, in centimeters cubed. So I know the volume of copper and the volume of gold. Now I'm told that the density of copper is 9 grams per cubic centimeter and the density of gold is 19 grams per cubic centimeter. Work out the mass of copper used. Okay, so we need to know the formula that links density, mass and volume. It's just density is equal to mass divided by volume. That's the formula. Okay, so in this case I've been given the density, I've been given the volume, I want the mass. Rearranging that, mass is going to be density times volume, isn't it? So mass equals density multiplied by volume. Okay, so my density of copper is 9 grams per cubic centimeter. My volume is 28 centimeters cubed. It's a good idea just to check you've got consistent units when you're doing these sort of things. So density is in grams per cubic centimeters, and my alloy is measured in cubic centimeters. So if I combine these together, I'm going to get grams then, aren't I, for my mass? So 9 lots of 28 then. 280 minus 28, what's that? That's 252 then, isn't it? So 252 grams. Now part B says work out the density of the alloy. Okay, now to work out the overall density of the alloy, we need to know what the total mass is and what the total volume is. Okay, so the total volume is going to be the two. It's going to be the two volumes added together, then, isn't it? Okay, so we had a volume of 28 and a volume of 41, didn't we? So 28 plus 41 gives me a total volume of 69. Now the total mass, now we found the mass of copper already in the last question. It was 252. So we need to add on the mass of the gold. Okay, so we need to do another mass calculation then, don't we? So to finish this off, we need the mass of the gold, don't we? So mass of the gold is going to be, remember it was density times volume, wasn't it? So the density of the gold times the volume of the gold. So 19 lots of 41. So that comes out to be 19 times 41. That's 779. So then the total mass is going to be 779 plus 252. Comes out to be 1031. Okay, so then the density of the alloy is going to be the total mass divided by the total volume. So 1031 divided by 69. What's that? 1031 divided by 69. 14.94. I'm going to round it off to 14.9. So 14.9 grams per cubic centimeter. A, B, C and D, E, F, G are parallel lines. That's already been marked on. You can see by those arrows at the end at C and G. And it tells me that B, E, H is a straight line. Okay, so we've got a pair of parallel lines and a couple of lines crossing them. So we need to work out the size of angle X. Okay, so angle X is that one over there. How can I find that one? Well, when you've got a pair of parallel lines and a transversal or a line crossing them, then it forms various angles, and you should know about corresponding alternate and co-interior angles. And I can see from here my X angle and my 25 angle are what we call co-interior angles. So this one and the X should add up to 180 degrees. Co-interior angles add up to 180 degrees, so 25 plus X is 180. So then taking 25 off both sides then should tell me what X is. So X is equal to 180 subtract 25, which is what, 160, 155, isn't it? So x is 155 degrees. And then B says work out the size of the angle y you must show your working, which may be on the diagram. Well, it will be on the diagram because I always do that. Okay, so where's y? It's down there. There's y. Look, we need to find that one. Okay, so again, we've got a pair of parallel lines, the yellow ones, and we've got this line here that crosses them, this purple one. Okay, so we should know that this angle here, the y angle, corresponds to this angle up here. Now that angle up there is made up of the right angle, which is 90 degrees, plus the 25 angle, which is equal to 115 degrees. So y and 115 are corresponding. So that is the answer. So I'm going to say y corresponds to 90 plus 25 equals 115 degrees. 115 degrees. It shows a polygon ABCDE, and that has been divided into 3 triangles. And we need to use the triangles to work out the sum of the interior angles of a polygon ABCDE, and we must show our working. Well, this polygon has got 5 sides, so it's actually a pentagon. So a 5-sided shape has got 3 triangles that go inside. Your maths teacher might have shown you how to derive the formulas for sum of interior angles of a polygon, and they do involve just dividing the shape up like this into triangles. You know that the angles inside the triangle sum to 180 degrees, so this triangle here adds up to 180 degrees. Now the triangle next to it also adds up to 180 degrees. Its interior angles there. And finally our last triangle adds up to 180 degrees too. So you can see that those 3 angles there form that interior angle of my pentagon. And then I've got another one there, look, and another one there, another one there, and another one there. So the 3 sets of 180 degrees from my triangle add up to the interior angles of my pentagon. So let's write that down below. What are we going to write? Angles in a triangle sum to 180 degrees. So interior angle of ABCDE equals 3 times 180, which is 540 degrees. Okay, here is a map of France, and we can see we've got several cities marked on the map, and we've got a scale down here. It says 1 centimeters represents 80 kilometers. Okay, what's the question ask? Over the page. What is the 3-figure bearing of Lyon from Bordeaux? The 3-figure bearing of Lyon from Bordeaux. So we're going to start in Bordeaux and we want to go to Lyon. Okay? Right. So you'll notice at the top here we've got a direction line for north, and 3-figure bearings are always measured clockwise from north. So let's just get my ruler out. So straight up in the direction of that north line, look, that's north. So if I want to measure a bearing, I should really start by putting a north line on the point where I want to measure my bearing from. So I want to go directly north from Bordeaux. So drawing an up arrow from there. Okay, so that's my north line. And from Bordeaux, I want to go in this direction, don't I? Oop. Now, so using a protractor, what you want to do is you want to measure that angle in there. Okay, can't really show a protractor so well in this particular application, but if you plonk your protractor on and measure it, you should find that you get an angle of 84 degrees in there, 84 degrees, and then so to write that down as a bearing, 84 degrees has only got 2 digits. Okay, we haven't got 84. We've got 85 or 95 or 175 or 05. Okay, so I think that perhaps I was just a little bit out of my measurement. I'm going to say it's that one there, 0.85. It says work out the actual straight line distance from Paris to Marseille. Work out the actual straight line distance from Paris to Marseille. So Paris is up there in the north, look, and Marseille is down in the south. So let's join them up with a straight line. Now with your ruler, you're just then going to measure that carefully then. Count the number of centimeters is between Paris and Marseille. Now again, because I'm using an emulated ruler here, I'm not going to be able to accurately measure it to show you, but if I did get a ruler out, I think it is around about 8.2 centimeters. Now if you're working from a practice paper from your school because they printed it out for you, sometimes these things don't get reproduced correctly at the right size, so you might find that yours is slightly bigger or slightly smaller. Don't worry too much about that. It's just one of those things that happens when schools give their students practice papers. What you just need to make sure you do is you take whatever measurement you've got there and you multiply it by the length to get the you multiply it by the scale factor in order to get the correct distance. So the scale factor is 1 centimeter represents 80 kilometers, and I've got 8.2 centimeters. Each one of those centimeters is 80 kilometers. I'm going to have to multiply these two things together. Okay, so again, using Napier's Bones grid, I'll do my 8.2 times 80. 8 8s are 64, 2 8s are 16, 8 zeros, well, 0 and 0. What's that then? Adding up along the diagonals, that's 0, 6, 5, 6. So reading around my answer, around the edge here, I've got the digit 6560. Now remember I had one number behind the decimal point there, so I'm also going to have one down here that's behind the decimal point. So my answer is 656.0 or 656 kilometers. So what is the actual distance? It's 656 kilometers. Again, if you're working on a reproduced practice paper that's been photocopied by your school, it might be that it got stretched or squished a little bit. So your answer might be smaller or bigger than that. Don't worry about too much. As long as you multiplied it correctly by 80, I'm sure you've got it. The diagram shows triangle ABC. Construct a bisector of angle BAC, then construct the perpendicular bisector of AC, and then shade the region inside triangle ABC that is nearer to AC than to AB, and nearer to A than to C. So we need a straight edge and compass for this, so let's get busy with that then. Okay, first up, make sure your compass is set up correctly. You need to have the pencil tip and the tip of the compass in the same place before you tighten it up. It's a good idea to keep yourself a little stumpy pencil like this one, so that you can swirl your compass all the way around without bumping into your hands. Okay. Then what we need to do is, what we've got to do, we've got to construct a bisector of angle BAC. So this is BA and C. So the angle BAC is this angle here. We need to cut this in half. Okay. Now to do this, you stick the compass tip at the angle, so in A, and we're going to draw an arc that cuts both those two arms of the angle. Okay, then we need to move our compass tip into that place where we cut it, and then into that place where we cut it and draw two extra arcs. Now those two will make a cross, and then we can then just join point A through that cross that we've made. Okay, now it doesn't matter what width you set your compass to, just that you don't move it while you're doing the construction, so you need to try and keep it the same. If you know it's moved, you probably want to stop and try again. Now, that seems to be a pretty good job. You can always check that with a protractor to be sure you've done a good job. Alright, next, construct a perpendicular bisector of AC. This is AC, so we want to cut this line in half. Now to do it, we need to set our compass so that it's slightly more than half the distance between the 2 points. Between half and 2/3 of the line is a good distance. Okay, and then we're going to draw two arcs from C and from A, and then hopefully they'll cross. I'm going to struggle a bit because it's going off the bottom from my paper here. So bear with me. Okay, so there's one of the arcs. Now move the point over to A and draw the second arc. Okay, I haven't quite got the cross at the bottom there. Let me just extend that one a little bit. Okay, there we go. So then those two arcs make 2 points of intersection, which you can then join up with your ruler. Okay, oh, I've got my ruler the wrong way around. You can see it's an awesome Pokemon ruler today. Okay, so there's my second line. So we want to shade the region that is inside triangle ABC that is nearer to AC than to AB. So nearer to AC than to AB is going to be below this angle bisector then, isn't it? And nearer to A than to C is going to be the left-hand side of this perpendicular bisector. So the area that we want is this triangle in here. So it's below the angle bisector and to the left of the perpendicular bisector. All done. Good job.
Here is a right angle triangle, and we need to show that x is equal to 12. Okay, so we've got two sides of a right angle triangle, and we're wanting to find a third side. So clearly we are dealing here with Pythagoras theorem. Pythagoras theorem states that c squared equals a squared plus b squared, where c is the long side and a and b are the two sides. Okay, so we're just going to sub into there and find what c is, and then say that's what x is. So c equals a squared plus b squared. In this case, c is x. X squared is equal to 7.2 squared plus 9.6 squared. So on my calculator, 7.2 squared plus 9.6 squared comes out to be 144. So then x is going to be the root of 144, which is 12.
In the diagram, the area of triangle ABD is 56. Work out the length of CD. Okay, in the diagram, triangle ABD. What is triangle ABD? Triangle ABD is ABD. It's this triangle here. And we're told that the area of this one is 56 centimeters. Now, we know that the area of a triangle is half its base times its height. So, area of triangle is half base times height. So, we know that the baseline of this triangle is 14, but we don't know the height. Let's call the height h. Okay, let's call it h. So, then my area of my triangle, which I already know is 56, is going to be a half times my base, which is 14, times my value of h, which I'm actually trying to find. Okay? Right, what can we do with this then? So, half of 14, that's 7, isn't it? So actually what I've got here is 56 equals 7h, and then dividing both sides by 7. Sevens into 56 go 8 times, so that means that h is equal to 8. Okay, so now we know how tall this triangle is. It's 8. Now we want to find the length CD, which is this length here. Okay, now looking at the right triangle, that has got a length of 6 and a height of 8. So I want to know the hypotenuse of that right angle triangle. Now you can do this with Pythagoras Theorem. I already know the answer because I know that 6 and 8 goes with 10. Okay, so I know already that it's 10 because I know what are the Pythagorean triples. Now these are very handy triples to know. So the first one is 3, 4, 5, and then any multiple of that is also a Pythagorean triple. So if you double each of those, you get 6, 8, 10. There's another one, 5, 12, 13. And knowing those means that if you have got a problem that involves Pythagoras Theorem on the non-calculated paper, you can pretty much always work out what these are without even having to think about it. But let's assume you didn't remember the Pythagorean triple. You'd have to use that c squared was equal to a squared plus b squared, wouldn't you? So c squared equals a squared plus b squared, which in this case would be 6 squared and 8 squared. 6 squared is 36, 8 squared is 64. Adding them together, you're going to get c squared is 100, making c equal to 10. So my answer is 10 centimeters, as I already told you. Okay.
Use trigonometry to work out the length x. I tend to remember ratios using the mnemonic SOHCAHTOA. Maybe you've got a different way. Maybe you can share it in the comments if you do. Right, so let's label up the sides. Here's my angle. This is the longest side, so that must be the hypotenuse. X is opposite my marked angle, and the other side is adjacent. Now, which ones am I using? I'm using the hypotenuse and the opposite, so the ratio I'm going to be using is sine. Okay, so the sine of my angle, sine theta, is equal to opposite over hypotenuse, which in this case, my sine 72 is going to be my x over 8. Rearranging for x equals, what we're going to do is move that 8 up there. So x is equal to 8 sine 72. Reaching for the calculator. Sine 72. Make sure your calculator is in degree mode. That could be a terrible, terrible mistake otherwise. Sine 72 times 8 is 7.608. I'm going to round that off to 3 significant figures. Does it tell me to do that? Nope. If it doesn't say, then 3 significant figures is usually a good one to go for. So I'm going to round that off to 7.61.
If ABC is a right angled triangle, AB is 20, BC is 37. Calculate the angle BAC. BAC, that's that angle there, isn't it? If I go from B to A to C, so yeah, that angle between BA and AC. Okay, so that's the angle we want to find. I'm going to call it theta, which is my want for angles. It's my go-to variable that I label them with, so that's theta. Now, this is going to be a straightforward trigonometry question, isn't it? I've got 2 sides and I want an angle of a right angle triangle. Okay, so step 1, write down our mnemonic for remembering the various trigonometric ratios, which is SOHCAHTOA. You might have something else to remember it. Then we need to work out which one of our three ratios we're going to be using. Now, we label up our sides relative to the angle given. So this one is opposite theta, and this one is adjacent to theta. So we've got the opposite and adjacent. So that tells me that we need tan. Tangent is equal to the opposite over the adjacent. Okay, so I'm going to write down the formula for tan. Tan theta equals the opposite over the adjacent. Okay, then all we need to do is sub the values in from our diagram to work out the answer. So the opposite is 37, the adjacent is 20. Okay, so then theta is going to be the inverse tangent of that, then 37 over 20. Okay, so reaching for a calculator, we're going to use the inverse tangent button, which you have to access by pressing the shift key first. So shift, tan, and then 37 over 20. Okay, so what's that then? That is 61.6 degrees. 61.6 degrees. Hello from Mr. Tompkins EdTech. Memberships are a feature on YouTube that allows subscribers to directly support creators and to also gain better access to them. As a member of this channel, you pay a small subscription fee and in return receive a range of additional channel perks. Here on Mr. Tompkins EdTech, I provide channel members with their own loyalty badge, which is displayed whenever you comment on any of my videos. I always reply to channel member comments first, and I try to answer all their questions fully. I upload exclusive member-only videos for all you EdTech enthusiasts, and I also post early releases of my popular exam paper walkthroughs. So if you can't find the paper you're looking for yet on my main channel, you'll most certainly find it first in the members only area. As a special acknowledgement and thank you, higher tier members can even have their name appear in the credits of my videos. So if you enjoy my content and you would like to support me make more of it, and at the same time enjoy some exclusive extra perks, then why not sign up today? In the diagram, ABC is a right angled triangle, P is a point on AB, BC is 40 meters, AP is 20 meters, and angle ABC is 30 degrees. Okay, now I do suggest you read through this information above the diagrams carefully and just double check that everything written up there is on the diagram. In this case it is. I've got the BC is 40, I've got AP is 20, and I've got the angle and I've got the right angle marked. But it isn't always the case, and it's always worth just double checking, because otherwise you might be staring at a problem that you can't solve because you don't have all the information. Okay, but all the information is on the diagram here, so we can proceed. Show that AC is 20 meters. Where's AC? AC is this side here, isn't it? I need to find that line, AC. How can I do it? Well, if we look at triangle ABC, that's just a right angle triangle, and I know an angle, 30 degrees, and I know a side, a hypotenuse, so I can find a second side, no problem, just using trigonometry, can't I? Okay, so if 30 is the marked angle, then the 40 degrees, that's the hypotenuse, isn't it? And AC is the opposite, and AB is the adjacent. Okay, so time to think about our mnemonic, SOHCAHTOA. SOHCAHTOA. Now, we have got a hypotenuse and we want the opposite. So which one is about O and H? It's the SOH part, isn't it? SOHCAHTOA. So that's the sine of an angle is equal to the opposite over the hypotenuse, if we're writing that out nice and long. Okay, so we're going to write out the correct trigonometric ratio. Next thing is to sub in what we know. We know the angle is 30, so let's put that in. So sine 30 is equal to the opposite, that's what I want to find, it's the side AC, and then hypotenuse we know is 40. So rearranging, multiplying both sides by 40, we'll cross multiply that 40 from where it is to the other side. So I'll get AC is 40 sine 30. Okay, at this point you'd reach for your calculator and then realize, oh, I don't have my calculator. This is the non-calculator paper. So am I stymied? Nope, because you should remember your exact trig value, shouldn't you, for angles 0, 30, 45, 60 and 90. If you didn't remember those, why not? You need to know them for your exam, don't you? Okay, there are various ways of remembering these values, but you should remember that the sine of 30 is a half. Okay, so I'm going to replace sine 30 from my knowledge bank of sines and cosines that I need to remember and sub it in. Okay, so 40 times a half is equal to AC, so that makes AC equal to 20 as required. A water tank, which is a cylinder with radius 40 centimeters and depth 150 centimeters. We're told that it's filling at a rate of 0.2 liters per second, and we're being asked, does it take longer than an hour to fill the tank? Well, in order to answer that question, we need to know what the capacity of the cylinder is to start with. So let's do that first. What's the volume of this cylinder? Well, a cylinder is a prism, and the area of a prism is equal to its cross-sectional area times its length or its height. So we need to work out what this bit is here. Okay, now that area is a circle, it's pi r squared times the height. So the volume of this is going to be, well, that's pi r squared, isn't it? So the volume of this cylinder is going to be pi r squared h. I'll leave the pi in for now. Do I want to leave the pi in? No, let's put it in. 3.14 times 40 squared times 150. So what's that? .14 times 40 times 40 times 150. So that's 753,600. Now that's in cubic centimeters. Now we're told, we should really know this, but 1 litre is 1,000 cubic centimeters. So if it's got a volume of that, then it can hold, let's divide that by 1,000 and find how many litres it can hold. So that's 753.6 litres. Okay, so if it's filled at a rate of 0.2 litres per second, how many seconds does it take to fill up? So time taken to fill up is going to be the volume divided by that flow rate then, isn't it? So taking time is equal to 753.6 divided by 0.2, and that equals 3,768 seconds. 3,768 seconds. Now this question is asking about time in hours, so we need to convert that to hours. So time in hours is going to be the seconds divided by 60 to get minutes, and then another 60 to get hours. So 3,768 divided by 60 divided by 60 is 1.046 reoccurring, which I'm going to round off to 1.05. So that's 1.05 hours. Okay, so does it take longer than 1 hour to fill the tank? Well, yes it does, because it takes 1 hour and 5, or 1 hour at 0.05. So the answer is yes, it takes longer than 1 hour. A cube has edge length 0.9 meters. Work out the total surface area of the cube. Give your answers in square centimeters. Okay, So notice first that that's in bold, and normally things in bold are there because students will otherwise not see them. So just take extra care when things are in bold. So square centimeters, this measurement is in meters we've been given up here, so we need to convert that into centimeters first, and if we're going to work this out in centimeters. So let's convert that to 90 centimeters. So this is 90 centimeters by 90 centimeters by 90 centimeters. Okay, now a cube is made up of 6 equal faces, and each face is a square, and 90 times 90 is the area of each square. So the total surface area of this cube is going to be the area of one face, which is 90 times 90, times by the number of faces, which is 6. So we're going to find 6 faces, and each face is 90 by 90. So the total surface area is going to be 6 times 90 times 90. So tapping that into the calculator, 6 times 90 times 90 gives me the answer of 48,600 centimeters squared. 48,600 centimeters squared. Okay, let's just write it down in the bottom. Oops, let's write in the bottom properly. Triangles A, B, and C and D, E, F are similar, and we've got them shown here. Now it says work out the value of x. Now, if two shapes are similar, it means their sides are in the same ratio. So these two sides match up on my diagram, and these two sides match up. And if we have a look at the relationship between 3 and 6, that's times 2, isn't it? So the 6 is twice as big as the 3. So it's got to be the same here from here to here. It's got to be times 2 as well. So whatever x is, when I multiply it by 2, I'm going to get 9. In other words, x is 9 divided by 2, which is 4.5. Okay, so that's my value of x, it's 4.5. And then it says write down the size of angle y. Well, as well as all the sides being the same ratio, in similar shapes all the matching angles are going to be the same. So that one and that one actually match up, don't they? So I know straight away that y must be the same angle. It must also be 53. So that needs to be 53 degrees. On the grid, draw a shape that is a reflection of the shape y. Show your mirror line. Okay, so they haven't actually drawn a mirror line on for us, so we've got quite a lot of freedom for this question. So let's pull out a ruler and draw on a mirror line for ourselves. I'm going to draw the mirror line here. Okay, and then let's reflect each of the points. When you're doing a reflection, you should really take each point in turn and work out where its reflection goes. So this point is 1 unit away from the mirror line, so its reflection will be 1 unit away. This point here is 3 units from the mirror line, so its image is going to be 1, 2, 3 units away as well, and so is that one at the top, and it's going to be 3 units away. Okay, once we've got all the corners, we can then draw the lines in. Like so. And then we have our reflection. And I say, as long as you've reflected it in a mirror line and drawn your mirror line on, you should get the mark for that. Triangle A and triangle B are drawn on the coordinate grid. Yes, they are. Part A says, draw the image of triangle A after a rotation of 180 degrees about the point 0, 0. Okay, so one way of doing this, if you're not very good at rotations, would be to go and ask the invigilator for a sheet of tracing paper. Lay that over the top of your diagram. Next, what you want to do is to put a little cross where the center of rotation is. At this point here, it's at 0, 0, isn't it? So if you put a a kind of a cross going through 0, 0. It will help you keep track of your rotations. Then you want to put your pen tip or your pencil tip at 0, 0 and turn the paper round. Okay, so when you get that little cross line up again for the first time, you'd have done a 90 degree turn, and then let it go around one more time so it lines up one more time, and you've got a 180 degree turn. Now, when you've got a 180 degree turn, they don't bother telling you if it's anti-clockwise or clockwise, because you're going to land in the same place. In this case, I'm going to have the points as indicated here. So I'm just going to remove the tracing paper carefully and put the image points in. So my 3 image points are going to be here, here, and here then, aren't they? Okay, so just carefully put the image points on, and then once you've got the image points on, you can then join them up with a ruler. Like so. So rotation, it should change the orientation and position of your shape, but not its overall shape. You can see it's still the same shape, it's just kind of upside down and move to a different quadrant. Okay, so that's my rotation. The next thing we need to do is to draw the image of a triangle after a transition of by the vector 2, -7. Well, a vector 2, -7, if you were going to draw that vector, it would be 2 along and 7 down. So I need to take each one of my points and move it 2 units to the right and 7 units down. So let's take this point here first of all, go in 2 units to the right, and 1, 2, 3, 4, 5, 6, 7 takes me to that point there. Okay, just going to rub that out again. So, okay, similarly, this point here is going to be translated to that point there, and this point here is going to be translated to that point there then, isn't it? Okay, once you've got your corners, then you can join them together with your ruler again. Part B says, describe fully the single transformation that maps triangle A onto triangle B. Now this is a 3-mark question, so you expect to give 3 bits of information in order to get to the mark. Let's go back and have a look at the diagram. You can see A and B, they're sitting next to each other. A is bigger than B. Remember, A is the original image object though, and B is the image. So A has been translated onto B. So I think this is going to be an enlargement. It's one of those crazy mathematical enlargements where your image ends up being smaller than the object. Okay, but we still call that in maths an enlargement, weirdly. But anyway, let's draw on some ray lines. Pick 2 points that go together. So this point here matches up with this point here on the image. So if I draw a ray line through those points, I'm going to use green. So like so. Just draw these faint really, and then I'm going to do the same. I'm going to find another 2 points that go together, so that tip of the triangle goes with that tip of the triangle down there, doesn't it? So I can put another ray line through those 2 points, and you should find that your ray lines converge on a particular point, and that particular point is known as the center of enlargement. In this case, it's this point here, isn't it? And that is the point -1, 2. Okay, so that's my center of enlargement. Now I need to give 3 bits of information. It's an enlargement is one thing. It has a center of enlargement at -1, 2. That's the second thing. And the third thing is going to be the scale factor. Now notice that this line here is 4 units and its matching side is 2, which is half as big. So that's telling me that the scale factor is a half. Okay, so they're the three things that I need to mention when I describe this transformation. It's an enlargement, 1 mark. Center, -1, 2. Scale factor, 1/2. Okay, they're my 3 bits of information for my 3 marks. 50 people took a test. Before the test, they predicted whether they would pass or fail. 30 people predicted they would pass. 26 of the people who predicted they would pass did pass, and 37 people passed altogether. Complete the frequency tree. Are you predicting that you're going to pass this test? Right, so 30 people predicted they would pass. So prediction, 30 people predicted they would pass, so 30 goes here. So if there's 50 altogether, then in the fail box it's going to be 50 subtract 30, isn't it? Going to be 20 people in there. So 30 people predicted they would pass and 20 predicted they would fail. Okay, so I've dealt with that first line there. 26 of the people who predicted they would pass did pass. So out of my 30 people who said they would pass, 26 did pass. So then that means that 30 subtract 26, or 4 of them thought they would pass, but they didn't, they failed. Okay, and it said 30, so we dealt with that one now, haven't we? So, and then finally 37 people passed altogether. So I know that 26 people passed up here, and I know that 37 people passed altogether. So 37 subtract 26 is the number of people who passed who thought they were going to fail then. So 37 subtract 26 is 11. So if 20 people thought they'd fail but actually passed, that means 9 people who thought they failed did fail. 20 subtract 11 is 9, isn't it? Okay. The table shows information about the distances walked by 120 students on their way to school in 1 week. And you can see that we've been given a grouped frequency table for those distances. So I've got 0 to 5. There are 20 students who walk between 0 and 5. 48 students walk between 5 and 10 miles. 30 students walk between 10 and 15 miles. And 22 walk between 15 and 20 miles. Now we're asked to work an estimate of the mean for this data. Now the problem is that this data has been grouped, so we don't have the precise values, but we're estimating. So we're going to use mid x as an estimate for each of these. So you find mid x by adding your two n values together and dividing by 2. So 0 plus 5 is 5, divided by 2 is 2.5. You're basically averaging out the two endpoints. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divided by 2 is 12.5, and 15 plus 20 is 35, divided by 2, 17.5. Okay, once you've got the mid-x, then we can work out f times x. So grabbing the calculator, 20 times 2.5, that gives me 50. 48 times 7.5 is 360. 30 times 12.5, 375. And 22 times 17.5, give me 385. Oops. Okay, and then I just need to add all those up to get a total. So 385 plus 3.75, sorry, 375 plus 360 plus 50. That gives me a total of 1,170. 1170. So then my mean then, my estimated mean, is going to be my sigma fx divided by my sigma f. In other words, the sum of fx, which is this value here, 1170, divided by my sigma f, that's the sum of my frequencies, which is this value, 120. Okay, just type that into the calculator again, 1170 divided by 120 is 9.75. Okay, so that's my answer, 9.75. In 1 hour, the shop sells 180 scoops of ice cream. The number of scoops of each flavor is shown in the table. Okay, so 45 scoops of vanilla, 75 scoops of strawberry, and so on. Now, we need to show this information in a pie chart, but before we do that, we need to work out what angles and things that we're going to use. So before we get onto the pie chart, we've got some work to do on the table first. Now, we've already told what the total was. The total number of scoops was 180, wasn't it? Okay, so 45 plus 75 plus 50 plus 10, that's 180. Now what we want to do is we want to take those number of scoops and turn them into the number of degrees that we need to draw on the pie chart to represent them. Now in a full turn you've got 360 degrees, haven't you? So the angle that we're going to use to show this needs to add up to 360. Now you'll probably notice straight away that 360 is twice as big as 180. So that means we can use 2 degrees to represent 1 scoop of ice cream that was sold. Okay, so that makes it very easy to work out the various angles that we need to use. We just need to double up then each of these. So my 45 scoops of ice cream, if I'm using 2 degrees per scoop, that's going to be a 90-degree angle that we're going to use. Strawberry, 75 times 2, that's a 150-degree angle. Chocolate is going to be a 100-degree angle. And mint is going to be 20 degrees. Okay? Okay, so moving on to the pie chart now. We've been helpfully given one of the lines to start off with. So this is going to be like one of the lines for our vanilla sector. Now vanilla was a 90-degree angle, so if we lay our protractor along that starting line with the center of protractor right at the end of the line in the center of the circle, we should be able to count around to 90, draw a mark, then remove the protractor and then draw on our 90-degree angle line. Okay, so that was 90 degrees, wasn't it? Okay, so this was then vanilla. Right, now the next angle we need to draw is 150. So again, we're going to take the protractor, but we're going to lay it on top of our newly drawn line, so the second vanilla line, and we're going to count around to 150. We're going to make a little mark, remove the protractor, and then join up the line that we made. Okay, so 150. It's going to be there then, isn't it? Okay, so then that is my strawberry section. That was 150 degrees. The next section was our chocolate degree thing, and it was 100 degrees. So again, we're going to lay the protractor along our last drawn line with the center of the protractor at the center of the circle. We're going to count up to 100, make a little mark, remove the protractor, and then we can draw our line in. Okay, so that was my chocolate section, and that was 100 degrees. Okay, and now the mint section, it kind of draws itself. Okay, so it's just the leftover part, isn't it? But you might just want to double check that that angle there is 20 degrees. So if you measure it, and it should be there or thereabouts. If you're like a degree either way, it's not going to make much difference. But just double check that it's there or thereabouts for 20. Okay, and that's that. We're done. The scatter diagram shows the results of 10 of the people in Lee's experiments. Here are the other 2 results. Okay, so I've got two more people to add. One was 47 years of age and took a time of 21 seconds. And the other one was 60 years of age and took a time of 34 seconds. So I need to add these to the scatter graph. Just make sure you're clear about the scale before you start plotting points. You can see from here to here there are 10 divisions, aren't there? So each one of those little squares is going to be worth 1, and the same up here as well. You've got 10 divisions spanning a gap of 10, so each one is worth 1. So a nice easy scale to use. So just find 47 on my scale this way and read up and read across from 21 and mark our cross. Okay, there's a cross there. And then the next one is it's 60 and 34. 60 and 34. 1, 2, 3, 4. There. Okay. Right. So now I've plotted those points. Part C says, what type of correlation is shown in the scatter diagram? Okay, if I get my ruler out, you can probably see that I've got a kind of band going up the data like that from left to right, sloping upwards. So got a clear positive correlation here. So I'm just going to write down the word positive. Question D. Estimate the time it would take a person aged 35 to complete the puzzle. Show your working to justify your answer. Okay, well, my working is going to be on the scatter diagram itself. Okay, so coming back to the diagram, if I put a line of best fit up my graph, just trying to angle it so you've got the same number of points on either side of your line. Something like that. Doesn't have to go through the origin, so don't force it through there. Something like that. You do get a bit of leeway when you draw these points. Probably it's like anywhere that this end is anywhere between there and this one is anywhere between there, and you usually get the mark, so it doesn't have to be an exact science, but a reasonable attempt at drawing your line of best fit is required. Okay, so once we've got our line of best fit, we can use it to help estimate our value. So I'm going to find 35 years of age on my diagram, and I'm going to read up to the curve and across. Okay, so there's 35. Reading up to the line. When I hit the line, I'm going to change direction and read across. And I'm reading that as about 11 on my scale. Okay, so estimate the time it would take a person aged 35 to complete the puzzle. It would take them 11 seconds. Part E says, Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. Is Lee correct? Show working to support your answer. Now, coming back to the diagram, if I put my ruler at 30, we can then count how many people are below it then, can't we? So how many is that then? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9 people are below 30 seconds, aren't they? And we've got 3 above that line there. Okay, just going to draw a kind of a dotted line along there to show our method. Okay, so we've got 9 out of 12 then, haven't we? Okay, so what's that as a percentage? 9 out of 12 as a percentage. Well, I just need to tap that into my calculator, don't I? 9 divided by 12 times by 100% to turn that into a percentage. So 9 divided by 12 times 100 comes out to be 75%. So, is he correct? No, it's not at least 80%, it's 75%. So Lee is not correct. Beth uses these 4 cards to make 4-digit numbers. How many different 4-digit numbers can she make that are greater than 8,000. Okay, Beth, what are you going to do here? 2, 4, 5, and 8. So we've got 4 places to fill. Let's think about what choices we have for each of these. Now, my number needs to be greater than 8,000. So I don't have a lot of choice for the first digit. It's going to have to be this one here, isn't it? It's going to have to start with an 8. So it's 8,000 and something. If it starts with 2, 4, 5, it's going to be less than 8,000, so it's no good. Okay, so it has to start with the 8s. That was only one choice I had for that. Right, what's the next digit? The next digit could be any of the other 3 numbers. So I've got 3 choices for that one. It could be the 2 or the 4 or the 5. So let's say I pick the 2. How many choices have I got left for the next choice? I've got 2 choices. Let's say I pick the 4. How many choices have I got left for the last one? I've only got 1. Okay, so then we can work out the total number of ways by then multiplying those choices together. So 1 times 3 times 2 times 1 should give me the number of ways of working out altogether. So 1 times 3 times 2 times 1 is 6. So there are 6 different numbers greater than 8,000 that she can make. Another way of doing it would be an exhaustive approach where you just wrote down all the various values until you had all the different ones. So 8,245, 8,254, etc. Until you got through all of them. Either way, you're going to get 6 values. The 4 possible outcomes of an experiment are A, B, C, and D, and we're told that the probability of A is 0.28. We're told the probability of B is twice the probability of A, so that's going to be 2 times 0.28. What's that? 2 times 0.28, that is 0.56. And we're told that the probability of C is equal to the probability of D. Okay, so we've got the events A, B, C, and D. Okay, so that is our outcome, and this is the probability. So we know that A is 0.28, we know that B is 0.56, and we want to work out, we know that C is equal to D. We don't know what those are. Let's call them X and X. Okay, and we want to work out what X is then for the probability of D. Now, because of probability, one of those things must have happened. All of those probabilities need to add up to 1. So if I take 0.28 and I add 0.56 and X and I add it together, I should get 1 for completeness. So let's add like terms together. What is 0.28 plus 0.56? 0.28 plus 0.56 is 0.84. So 0.84. X plus X is 2X plus 2X is equal to 1. So I've got myself a little linear equation in X that I can now solve. So taking my 0.84, moving to the other side of the expression, I'm going to get 2x is equal to 1 subtract 0.84, which is 1 subtract 0.84 is 0.16. So I know that 2x is 0.16. So then x is going to be 0.16 divided by 2. So divide that by 2 and I'm going to get 0.08. That doesn't look right. Yes, it does. 0.08. So that is going to be my value of D and C. And our answer wants us to find the probability of D. So that's 0.08, one of the x's. Hannah wants to display all the possible outcomes when rolling 2 fair 6-sided dice. Give a reason why a tree diagram is not the best method to use. Well, in a tree diagram, you're doing a branch, aren't you, for every possible outcome. So when you throw the first dice, you're going to have 6 possible outcomes. So if you were going to draw this as a tree diagram, you'd have 1, 2, 3, 4, 5, 6 different branches like that. And then each of your branches is then going to have 6 more branches. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's gonna be like a forest, not a tree, isn't it? So there's so many branches at the end, it's just confusing. So the reason why I wouldn't use it is that it is too many branches. So draw a sample space to display all the possible outcomes. That's a much more sensible idea, isn't it? Now, a sample space, you're going to have a table, and you're going to have a column for each outcome from one event and a row for each outcome from the other. So I can get a 1, a 2, a 3, a 4, a 5, or a 6 on my first dice. I can get a 1, a 2, a 3, a 4, a 5, or a 6 on my second. Now, what you put in the middle depends on what the question is. Now, if it was the sum of the two dice, then you'd put the sum in the middle, so 1 plus 1 is 2. If you were subtracting, 1 subtract 1 would be 0. So it really depends. Now, in this case, I can see in the next question that we're looking at adding them together. So I'm going to put the sums in the middle here. So 1 plus 1 is 2, 1 plus 2 is 3, 4, 5, 6, 7. 2 plus 1 is 3, 2 plus 2 is 4, 5, 6, 7, 8. 3 plus 1 is 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, 12. Okay, so that's my sample space for adding the two scores together. And then in the last part here, it says show that the probability of the score of the two dice adding to 11 is 1 over 18. Okay, well, there are 36 outcomes altogether. Now, probability is equal to successful outcomes over total outcomes, isn't it? That's the definition of probability. In this case, there are 36 different outcomes, each one of those numbers in the sample space. 6 times 6 is 36. So that's the number on the bottom. And how many 11s can we see? Well, I can see 1 there and 1 there. So that's 2 altogether. So there are 2 successful outcomes out of 36. Dividing top and bottom by 2, that's going to give me my 1 over 18 as requested.
This is a Venn diagram, always my favourites. A school has 86 teachers, 42 are male and 44 are female. 1/3 of the male teachers have blue eyes and 1/4 of the female teachers have blue eyes. So we're going to put that on a Venn diagram. For A, we're told that the universal set is teachers in the school. M is the male teachers and B is the teachers with blue eyes. We need to complete the diagram. Okay, so where shall we start? I think if we look at this bit here, 42 are male and 1/3 of the male teachers have blue eyes. That means we can work out what the intersection is going to be then, don't we? So we've got 42 male teachers altogether and 1/3 of them have blue eyes. So 42 times 1/3, or 42 divided by 3. 3 goes into 42. Is that 14 times? So that means there are going to be 14 male teachers with blue eyes. So that means the intersection between M and B is going to be 14. And now I can start working out the rest. So if there were 42 male teachers altogether, of which 14 had blue eyes, then 42 subtract 14 will be the number of teachers who are male and don't have blue eyes, which is 28. 1/4 of the female teachers have blue eyes. How's that going to help us? Oh, okay, I suppose that tells us the bits that are in the number who are in B and not in M. And we know there are 44 female teachers, and 1/4 of that would be 11. So that is that one there then, isn't it? So 11 teachers have blue eyes and are not male. And now we can work out what's left. We've got 86 teachers altogether. So then
86 minus my 3 other parts, 28 and 14 and 11, so that's 42 plus 11, 53. 86 to subtract 53, which is 33 female teachers with not blue eyes. That's what's going to go there, isn't it? Part B says one teacher who has blue eyes is chosen at random. Work out the probability that the teacher is male. So we want the probability that the teacher is male given that they have blue eyes. In other words, if we know that the teacher is in this group, what is the probability then that they are here? So that's going to be, there are 14 teachers with blue eyes out of a total population of 25 teachers with blue eyes. So that is going to be 14 over 25. 2 ordinary fair dice are rolled. Complete the tree diagram. Okay, so we've got our rolls for the first dice on the left, and the probability of getting a 4 is 1 over 6, and we know that the probability then of not getting a 4 is going to be 5 over 6, because all the branches of each part of a tree diagram should add up to 1 because of completion. So again, up here that should be 5 over 6, 1 over 6 and 5 over 6. Okay, so then circle the probability that both dice land on 4. Now both dice land on 4 is this root here, so that's the probability of 4 and 4. Probability of 4 and 4 is going to be those two values multiplied together. Then it's going to be 1/6 times 1/6, which is 1 over 36. Is that one there? Part C asks us to work out the probability that at least one of the dice does not land on 4. Now the probability at least one not 4, that's basically 1 minus the probability of them both being 4s, which is 1 minus 1 over 36, which is 35 over 36. Now you could do it the long way and work out that root, and that root and add them up, but because all of the outcomes add up to 1, if I know the first one, I can just take it away from 1 and it will give me the remainder.
Phew, well that was a long session, so well done for getting all the way through it to the end. Please do like and subscribe if you found it helpful, and share the link with your friends. This really helps the channel out. Past paper practice is one of the best forms of revision in the run up to the exams. So be sure to check out my past paper walkthroughs by checking out the playlist linked on your screen. See you on the next video.